All right, good morning, guys. It's 11:30. Um, it's 11:30 and July 11th. We're going to record a session. So I am working on your, let me double check that I'm recording. Yeah. So I am working on your study guide for exam 3. So far, this is what we have here. It will be on July 14th, this Thursday. On that day, I won't meet with you officially. There won't be any class. You will take the exam. The exam will be available for 24 hours starting 8 a.m. on July 14th. On the 13th of July, I'll be here in this room, but nothing will be recorded. I'll be here to take your questions. I see a student coming in. Thank you, Brianna, for coming in. I'll be with you in a minute. So exam, the third exam is on July 4th. The study guide is being prepared. As of now, we have done these 3 packets and these problems, okay? Packet area perimeter 2 was wrapped up last class, and we didn't do 15, and I did not list 15. So the plan today, I'm going to ask the student who is in class what her questions are. I'll start with that. But other than that, the idea is to go over well, let me actually go over something no matter what, okay? So in the notes folder, the next packet, okay? So what are the next packets, guys? I think if we finish these 2, volume surface area 1 and the elementary one, we'll be in good shape. Am I gonna do every single problem? Not really, but I think we may have time to do 1 or 2 more. I don't remember, but that's about our syllabus, okay? That'll wrap us up. Other than that, another important thing to mention is this. In the notes folder, you're going to see a packet called surface area of cylinder. This is something you guys are supposed to teach in middle school. And we have done it in 3190. I'm not going to prove it, and I'm not going to ask you to prove it on the exam, but this is there. You should know it. We're going to use the formula. We're going to go over it. There's another formula like this, and in the same folder, notes folder, and it's called volume and surface area of a cone. Same thing, we did it. We're not going to worry about it too much. We will use it, however, to do the problems. Another little third announcement, that is that you want to, when you take your exam 3 and the final, it's a good idea to have this formula sheet in front of you, 3D formula sheet. You have seen it. If you had me for 3190, you have seen it, but even if you didn't, there's nothing going on. Volume and surface area of a cone, volume and surface area of a cylinder, and volume and surface area of a sphere. You need to know them now. Again, these are the ones you should be able to, you should know how to prove. You will be teaching those things. And the rest of them, this one, this one, this one, this one, we use it. That's all. Calculus is needed to prove them, and we do it in college level classes, really in Calc 1, Calc 2. Actually, to be honest, in Calc 2. So we are not ready to prove those. The 2 circled ones, you should know the proof. The proofs are there. If you want me to go over the proofs, you have to either email me or tell me, otherwise I'll assume you guys are familiar with it. Okay. So other than that, Brianna, how are you doing?
Good.
Good. Let's start. Let's see if you have any questions. You heard me talk, so if you have any questions about those, that's fine. If you want me to do something, if you have any specific questions, go for it.
I'm okay right now.
Okay, so let me just go ahead, keep on recording, and I'm going to pretend we have a student, and I'm going to just not like record, I'm talking to a blank screen. If you have any questions, feel free to interrupt. All right, guys, so here we are. Again, I am working on, let me see, let me take a look. Okay, volume surface area. Now, some of the first problems are very easy. You're going to do them. Okay, there's nothing going on. We have done a lot of harder things. Okay, but you're going to try, they are on the syllabus, but I'm going to try some of the ones that are a little more difficult. And I'm going to access the same document from my hard drive. So that's the deal. Okay, we're working on volume and surface area 1. You're going to see eventually it's going to be a little messy. I don't think we'll get to the messiest parts today. So these sets that I've been uploading, the answers are in the bottom. I believe the answers are pretty accurate because I've used them. If you catch something that you think is a typo, you just have to tell me, email me. I think your answer is wrong. I hope that won't happen. Oh, okay. So this is volume surface area 1. There's really nothing going on. Absolutely nothing. They want you to find the volume of this. You can. We have done. They want you to find the volume of surface area of this. You can. We have done many problems. Most of them are harder. By the way, last class, we did a set of volume and surface area problems. I think we had 5. Those structures were very different. Let's do some of these. Okay. I'm going to do one of them. They're parallel, really. So let me see. So this is going to be our classwork packet. I will, for instance, I will assign 1, 2, 3, 4 for sure, but I will only do 3. 1 and 4 are too easy, and we have done things far more difficult, but you can use it in your class. Let's do this one. And number 2 and 3 are parallel. We're going to do 3. Okay, now I'm going to take this problem to my Polypad, which is that mark. Give me a second. Okay, let's take it to Polypad and read the question carefully. All right, now the surface area of the cube is 486. What is surface area? Surface area is area of the cube. This is not a unit cube, so don't assume this is 1, this is 1, this is 1. We can't say that. So another thing we want you to remember is that a cube, for the rest of this semester, you want to remember a cube has 6 faces, 8 corners. I know I can only see 7. There is 1 in the back, 8 corners and 12 edges. Where are the edges? Well, the edges are, sorry guys, the edges are, I'm going to draw them. I say they're on the ceiling, 4 edges on the ceiling. 1, 2, 3, 4. 4 edges on the floor. Yeah, you can see the 2 on the in the back, and then 4 between the walls. I'm going to use green. So again, you have to remember a cube has 6 faces, 8 edges, 12 edges and 8 vertices. We're going to say vertices, corners are the same. Now I'm not going to use edges and vertices today, right now, but it has 6 faces. So I'm going to take 486. Excuse me. I like this better. 486. And divided by 6, there are 6 faces. I wonder what I get. Guys, I'm going to do my calculator here. You can use your own hand calculator. 486 divided by 6, 6 faces. I get 81. Okay, so I'm going to write 81 here. Now, that tells me this square has an area that's 81. Just call this edge x, this edge x. Then you can set up this equation. X squared is 81, and x is square root of 81, which is 9. So this is how we can find out each edge is 9. And now they want you to find the volume of the cube, which is clearly length times width times, sorry. I don't know what's going on, guys. Which is clearly length times width times height. 9 times 9 times 9 is equal to something. And we're going to find out right here. I'm going to write 9 to the power 3. That's 9 times 9 times 9. I'm getting 729. And I'm pretty sure the answer is correct, but I'm going to check my answer. I'm going to say, let's see. I'm going to say unit cubed. Okay, you want to write the answer? This is my answer. I'm going to I don't know what's going on here. Sorry about that, guys. Just a moment. Why wouldn't this go away? Give me 1 second. Somehow it's ticking. Okay, it is 729 unit cubed. That's my answer. I'm going to quickly check my answer. I'm going to pause here a little bit. So number 3, we're getting 729. Not bad. It says, sorry, it says unit feet cube. Okay, sure. Let's fix that. FT to the power 3 because the answer is in square foot. Let's pause there a little bit, see if Brianna or anyone else has any questions. If anybody else is here, I don't think we have too many people here. What do you think, Brianna?
Seemed pretty good.
Awesome. So moving on. Okay. So guys, listen to me carefully. Let's read it. Consider 4 unit cubes when glued together. Let's try this. Okay, let's try this one. Okay. Once again, guys, this one is not difficult. Well, I'll do this one. Okay. Just for the heck of it. We did 3. So let's try this one. It's not difficult, but I'll do it. And actually, let's bring it to my Mathicon Polypad. I can almost do it here, but I like that Polypad better. So let's see. The shape below, it's a little bit of a review. Doesn't hurt. So the shape below is made with identical unit cubes. The good news is these are unit cubes, so you don't have to do a lot of calculation. Each edge is 1. And they want you to find the surface area and the volume. Well, the volume is very easy. You count the cubes. And the best way to count it is somehow, you're not counting the squares, you're counting the cubes. So what's the best way to do it? Let's do it this way. Check mark. 1 cube, 2. Well, that's not the best choice for my color. Well, let's take star. How many cubes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's only 1, guys. Okay, don't assume there are 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm getting 10, so my volume is 10. Okay, I'm going to write it like so. 10 u to the power 3. Done. Easy. Nothing going on. Surface area. Okay, surface area is tricky. You want to develop a skill that works for you. Even if you develop a skill, you actually have to develop multiple skills. Some structures won't work. Your skill won't work on, no matter what your skill is, what your strategy is, it won't work on all solids. So for this one, guys, I'm going to quickly run over every cube and see how many faces are visible on that cube. My choices are very limited. Mostly it'll be 2, 3, 4. It won't be 1 and 6 generally, okay? So it could be 1 actually. Basically 1, 2, 3, 4, 5. So very carefully, I've counted my 10 cubes. I am going to write, this one shows 5 faces, okay? I can see 3, 1 is in the bottom, 1 is in the back. This one over here shows 4 faces. I can only see 1, but I have to understand that. Now this one shows 4. I know I can barely write 4. This one shows 4, and this one shows 3. 1, 2, and the bottom 3. This one shows 5. 5s are easy at the end point, 5 and 5. And this one shows 3, easy to mess up. This one shows 4. Now you can do your surface. See how differently I did it? There is no formula. What's your surface area? And it's very easy to miscount. So very carefully, how many fives do I have? 1, 2, 3, 4. I'm going to write it like so. How many fours? 1, 2, 3, 4 fours. And I think I have 2 threes, if I'm not mistaken. 20, 16, and 6. And 16 plus 6 is 22. 22 is 42. And we'll check my answer. I hope it's 42u square and 10u square, but let's, well, of course, if I messed up, I'll have to fix it. Five. Not bad. I got the right answer right here, okay? All right, back. Let's pause it a little bit, okay? See if we have any questions. Again, it's not a difficult one. You just have to get a feel for it and do them. And there are tons of practice problems. I did a little set, and there's a bigger set in the definitions folder for under volume and surface area definition. There are tons of them. The structure you will see will be a little different from the ones I gave you. Excuse me. All right. I think these are some of the easier ones. Let's try the next one. Let's try number 6. I don't even know what it is. I did it a long time ago. So let's read it very carefully. Consider 4 unit cubes. We want to glue the unit cubes so that each cube. Okay, I'm going to skip number 6. The only reason I'm going to skip it, guys, this problem is really designed to be in class, and I generally give my students a bunch of cubes, and they do this and they figure it out. So this is not going to be on your exam. I'll be careful. I'll say 1 through 5. So we have done 1 through 5. We're going to skip 6. This is interesting. We'll try it, actually. We'll try number 7. Even this one is good for our classroom. A little hard to do on the computer, but I'll try my best, guys. So the question says, make it a little bigger. This one is actually okay to do online. Okay. Made it way too big. All right, guys, let's bring this guy to the next page. Okay, object shown below was made with identical unit cubes. Assume you can break the object into unit cubes. Well, how many are there? Let's find out. I know I didn't read the whole question. I have 1, 2, 3, 4, 5, and 3, 15. And in the bottom, I have 15. I have 30 cubes here. There are 30 cubes here. That's easy. But look what they're asking you to do. What is the length of the largest cube you can make with all the unit cubes removed from this object? So you have access to 30 unit cubes, 30. What's the largest cube you can make? Well, if with 1 cube, you can make a 1 by 1 by 1. Okay, so it's a tiny cube with 1 cube. If you want to make a cube that's 2 by 2 by 2, and that's going to be, you will need 8. You will need 8 cubes. We're going to write 8 here. Okay, that still leaves many more cubes. Try the next one. Try to make a cube that's 3 by 3 by 3, and that's 27. We're getting there. So I need 27 cubes to make a 3 by 3 cube. So if I grab 27 from here, I can make it. The next one will be too big, and I'm going to show you. If you say, well, I still have 3 cubes left over. Yeah, I'm going to try 4 by 4, but 4 by 4 by 4, 4 times 4 is 16. 16 times 4 is 64. That's too many, and you don't have enough cubes to make a 4 by 4 cube. So the answer is, with all the unit cubes, what is the length of the largest cube? I'm going to say the answer is 3. Again, it doesn't want you to find the volume. It says the length. It'll be a 3 by 3 by 3 cube. That's your answer. It wasn't that bad. It's something you have to read and process. You know, you see it for the first time on an exam and you're a little baffled. What does it mean? Well, that's what we mean. Moving on. Brianna, if I'm going too fast or something, just let me know. It's the same thing. I'm going to do it actually just for fun. We're going to do some problems that are going to be messy, and I'm not procrastinating, but maybe I am at a level, but we're going to see. This one is easy. I don't want to get too ahead. Sometimes when you're doing online class, you get a little too ahead, and so I don't want to get too ahead. So let's try this one. Same story. Okay, how many cubes are here? I have 4 and 4. I have 16. I have 16. I have 16. 48 cubes. I have 48 loose cubes here. Okay, if you want to make a 1 by 1 by 1 cube, you're going to only need 1 cube. That's not the largest you can make. You have plenty more. If you want to make a 2 by 2 by 2 cube, you're going to use only 8 of them. Not good enough. I think the answer is 3 by 3 by 3. It's 27. I know that's fewer than 48 because 4 by 4 by 4 is too many. You don't have enough. So the answer is, what is the length of the largest cube? I'm going to say 3, like before. Another easy one. All right. Okay, let's do a hard one. Okay, these you're going to try. Okay, I actually took them from a middle school text. They're very nice, pretty pictures. You're going to try them, nothing going on. These are unit cubes, find the volume and surface area. Now I'm going to try this, okay? And this is a little hard, guys. And I'm glad we have somebody here because they can kind of keep me straight if I mess up. Okay, make it a little bigger. And you're going to see some of these hard problems on the exam. Those of you who had me in the past, you know that. I do give difficult problems. So again, this is slightly difficult, not beyond us. I mean, this would be considered a hard problem from a 9th grade, 8th grade text. Even I've seen some of them in middle school. All right, here we go. The first difficult problem. The bigger cube is made with 27 3 by 3 by 3 smaller unit cubes. So the pink cube and the gray cubes are unit cubes. Find the volume and the surface area of the object form when the smaller dark cubes are removed from the bigger cube. Okay, now, a couple of things. If I were to give you this on the exam in a physical classroom, I will have to print it black and white. However, this one will be in color, okay? So colors matter. Let's pretend colors matter, and they do. I am only talking about these 3 cubes. I am not suggesting that the back, there is a little gray cube, there's a little gray cube, there's a little gray cube. I'm not suggesting that at all. If I were to suggest that, I would tell you all the faces look the same, I would say something like every face of the large cube has a gray cube in the middle. All the rest of the cubes are pink. I would say that. Since I didn't say it, I'm talking about 3 cubes. Now the volume is very easy. Okay, so basically the original volume before you remove anything is 3 by 3 by 3, which we know is 27. Now, but my new volume, these are all unit cubes. My new volume is going to be 27. I'm going to remove 3 of them, just 3. Don't assume it's 6. I'm going to remove 3, and the answer is 24 unit cubed. Done. The volume is very, very easy. You have a stack of 27 cubes. You're going to remove 3 of them. What are you left with? And assume things don't collapse. Everything stays where it is. The answer is 27 minus 3 is 24. And I'm going to check my answer, but not right now. I'm pretty confident I'm correct on this one. There's nothing going on. Surface area is a little difficult, guys, so bear with me. I'm going to erase all this. All right, of course I deleted that, but we're going to bring this guy back. We're going to fix him here so that he can be deleted. All right, guys, what's the original surface area? Write it down nicely. Large cube. What's the original surface area, guys? It has 6 faces. It has 6 faces, and each face has 9 squares. Surface area is about squares. 3, 3, 3. So the answer is 6 times 9 is equal to 54. I'm not going to worry about the unit. I'm going to put it in my final answer. Now, so far so good, hopefully. This is where it gets hard. When I remove this gray cube, what happens to the surface area? Excuse me. What happens to the number of squares that are visible? Okay. When I remove that cube, I lose 1 square from 54. But I gain 5. I gain 1 here, 1 here, 1 here. Once you remove the gray cube, there is an indentation, and it has 5, the bottom of this cube, the left side of this pink cube, the right side of this pink cube, the top of this pink cube, and the back. There is a cube in the back. So you're going to gain 5. You're going to remove 1. You're going to add 5. And this actually is same as 50. It'll be 50. Once again, every time you remove a gray cube, you're losing a square, you're gaining 5 squares. And it is same as saying you have a net gain of 4 squares. Now I know we are recording. I'm going to show you this a little nicely visually, okay? I hope I have a cube here. Now the colors are looking a little different here, and that's okay. Okay, so claim we are making, the claim. Now, if I change the colors to the way I did, there are no edges in the software, it'll look funny. So what happens, guys, if I remove this cube in the middle that looks red now, I'm going to hammer it. Take a look what happened. I gained 4 new faces, I lost 1. This face, this face, this face, this face, and this one at the bottom. I gained 5 and lost 1. So you have to understand each gray cube, the removal of each gray cube.
Question.
Go ahead, Brianna.
How would it be 50 and not 58?
Say that once again.
You said it's 54 minus 1 plus 5 equals 50. Why would it
You're
not be?
right. Absolutely. Absolutely. My bad, guys. Thank you, Brianna. Okay. So let's do it nicely. Absolutely. 54 minus 1 plus 8. And if you do it correctly, like Brianna, not like me, you're going to get 58. Sorry about that. Yeah, very good. All right. So basically, thank you. Each removal adds 4 squares. I'm sorry. Each removal adds 4 square. And the visual is right here. Okay. The visual is right here. So I don't have 1 removal. I have 3 removals. We just showed 1 to understand what's going on. So 3 removals. Each removal adds 4 additional squares. 3 removals will add 3 times 4 or 12. And this turns out to be 66. And I'll certainly check my answer. Unit square, and our volume was, that was easy, 27 minus 3. Let me go check my answer. 66 and 24, that sounds about right. Brianna, does that make sense when we are saying we add 4 squares when we remove a gray one?
Yeah.
Good, very good. And it's the hardest part, as we haven't done this, and I'm talking just not to one person who was in class. Go to this software, 3D Slash, okay? Now, it's a free software. You have to log on, just give them your name and email, a valid email address. You'll be able to. It's a very nice tool for teachers to have. You can make cubes. They're very easy. And those of you who had me for 30 minutes, you've seen it, nothing new. It's really nice. And it's almost better than having real cubes in front of you because they're expensive and they're messy. Nobody's saying don't bring real cubes. Real cubes are real cubes. But this is also very nice. And you can really get rid of this. These are your gray cubes. Each time you remove, you gain 4 additional squares. Good. All right. I think I don't need 10 minutes to do. I'm going to continue doing it. And again, Brianna, if this kicks me out, I'll always come back. And the way it has been going, I spent about 45, 50 minutes recording, and then I hang around here. So if it accidentally kicks me out in 8 minutes, it will. Let's see what the next problem is. And the plan is to continue working on it. We did this. Okay, this is a good one too. I think I'll be able to handle it within 8 minutes. All right. Now, this one says, find the volume. Well, the volume is very easy. The original volume, 27, but subtract 3. You're only subtracting the gray ones. The answer is 24, like before. Unit cube, nothing going on. Surface area is a little tricky. The original surface area, again, is 9 squares per face. There are 6 faces. I'm just going to write 54. Okay? This one is a little tricky, guys. Okay, I'm going to show you in the visual 3D in a second, but let's say we don't have it. How many faces am I going to lose when I remove the 3 gray cubes? 1, 2. Well, let me do it nicely. Let me do it nicely. 1, 2, 3, 4, and there's 1, 5. So I'm going to lose 5. Now, I am going to gain some, and I have to carefully account for it. Okay? The ones I gain, guys, I'm going to try to explain this way. There's 1 in the bottom of this, 1 in the bottom of this, 1 in the bottom of this. Then I'll gain this 1, 3, 4, 5, 6, and 7. And I'm going to gain 1 here, 8, and I'm going to count it again. I'm claiming I'll lose 5 squares, gray squares. How many new pink squares will be exposed? The answer is 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm getting 9, so I'm going to add 9. And this time I'll try not to make a mistake. 54 minus 5 is 49. 49 plus 9 is 58. My surface area will be 58 units square. Let me quickly go check the answer. There's no need to, if I already made a mistake, there's no need to go over. I have to fix it first. 5824, that's a good sign. Let's look at it this way. Let's go back to our this cube. Let's take this guy in. Okay. Again, I have to use different colors here because otherwise this software doesn't have edges. So let's remove this. I'm going to lose 1, 2, 3, 1 here, 5. So that's easy. How many do I gain? Sorry. Okay. We gain, let me take this guy here. Bring this guy here. Remember, as promised, guys, we will gain 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's where 9 is coming from. And I'll show you. Take a look. 1, 2. You're going to gain a couple here. 1, 2, 3, 4, 5, 6, 7, and 3. So what do you think, Brianna? Does that make sense at all?
Yeah, it does.
All right, so I'm going to get out of this. It's going to kick me out any moment, but I will come back. I'm going to do a few more problems, maybe for another 10, 15 minutes. Okay, feel free to come back. Hopefully I'll see you soon, but let's get out of this. It's going to kick me out.